piano, guitar, drums. What do the instruments all have in common? They're a group of musical instruments. The symbol used to represent sets is a curly bracket, and it's read as the set of, or it means a set of. Right. Take for example, if I were to put vowel inside of the curly bracket, it would be read as the set of vowels. The items inside of a set are called elements or members. Example, the set of vowels. The members would be A, E, I, O, and U. To master sets, we must know the different types of numbers. Natural numbers, these are a set of counting numbers. 1, 2, 3, 4, 5, 6, 7, going on and on. Whole numbers. These are a set of counting numbers and zero. So it starts from 0 and it goes on to infinity. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and whole numbers keep going on and on and on and on. Integers, these are the set of negative and positive counting numbers and zero. And it starts from negative infinity and it goes on to positive infinity. So examples, negative 5, negative 4, 0, 1, 2, 3, 4. You have rational numbers. These can be written as fractions. So negative 5, a half, 0.35, basically. Irrational numbers are numbers that cannot be written as fractions, like pi. That's an interesting one. Alright, so let's break this down together now. Real numbers is a set of rational and irrational numbers combined, like this. First, you have your set of natural numbers, which is a smaller set than your set of whole numbers, but all natural numbers are whole numbers. Then all your whole numbers come under the set called integers, represented by a capital Z. Q is sometimes used to represent rational numbers, so all integers are rational numbers. And then you have the irrational numbers different, but when they combine together, we get what is called a set of real numbers. Right, good so far. Alright, now natural numbers are numbers that can be broken down into smaller categories or groups, such as even numbers, numbers that are exactly divisible by 2, so 2, 4, 6, 8, 10, 12. Odd numbers, numbers that leave a remainder of 1 when divided by 2, 1, 3, 5, 7, and it goes on and on. Prime numbers are natural numbers that have two factors, 1 and themselves, while composite numbers, on the other hand, are natural numbers that have more than 2 factors. Alright, and we get right into our exercise. Alright, so question 1 says, list the elements of each of the following sets. So we have a set of A equal a set of even numbers less than 13, B equal a set of, alright, so we get right into it. So even numbers less than 13, we're thinking about 2, 4, 6, 8, 10, 12. B is prime numbers between 15 and 30, so that's 17, 19, 23, and 29. Please remember that prime numbers have 2 factors, 1 and themselves. Multiples of 5 between 12 and 45, so I'm going to have 15, 20, 25, 30, 35, 40, 45. Alright, and then you have whole numbers greater than 10 but less than 20. So you know we're going to start counting from 11 and we'll stop at 19. Even numbers from 4 to 16 inclusive. Inclusive means that those boundaries 4 and 16 can be included if they are actually even numbers. Activity 2. Describing words each of the following sets. So P, you have 2, 3, 5, 7, blah blah blah. 2, 3, going down to question 4, and you can pause it and you can do the questions and come back and look at the answers to see if your answers are correct. Alright, so you can always pause and come back. That's up to you. Alright, so the first set, of course, when you look at those, you realize that those are prime numbers between 1 and 18, or I can say between 2 and 17 inclusive, which means that 2 and 17 would be included. You have 25, 30, 35, 40. Clearly those are multiples of 5, so I can say multiples of 5 between 25 and 45 inclusive, which means I'm including 25 and 45. It can be described in different ways. You don't always have to use the same description. Now, R equal WXYZ, which of course is a set of the last 4 letters of the English alphabet, right? So the set R is a set of the last 4 letters of the English alphabet. Question 4, that one is interesting. 1, 4, 9, 16, 25, 36, 49, those right there are unique. If you notice, 1 is 1 times 1, 4 is 2 times 2. So those are what we call square numbers. Alright, so the first 7 square numbers are those.